Okay, so today we're going to go ahead and finish up 6.2 dot product. Were there any questions on the homework if everybody got started on it? Anything I need to go over? No? All right, so we're going to talk about projecting one vector on another. So there are times when we have two different vectors here, like such, and I am interested in projecting this vector down to here. So in other words, I'm going to resolve this vector into two vectors, the vector from here to here, and the vector from here to here. So let's say that if this was the original vector, I am splitting this vector into one that is going the same direction of this vector and a perpendicular vector this way. In other words, if this is u vector, and we'll call this v vector, I am projecting the u vector, projecting it. If I had a light up here and I'm shining a light, I am projecting this vector onto this vector. We call that projection of u vector onto the v vector. Okay? So if you look at the middle of 470, there is a definition there, or there's an equation there, and then it shows that u dot v squared. Okay? So, I can tell you right now where you're going to get confused on this. So, first of all, this is projection of u onto v. So, if you look at the equation, this guy here is a constant or a scalar. It is not a vector. This is the guy that's the vector right here, which makes sense because you're going to be going in the same direction as v, so it would make sense that v would be here. Okay? So the way to memorize or remember this equation is that the v has to be here on this side, okay, when you're projecting onto the v vector, and then you'd have the dot product divided by this guy squared down here. Okay, so that's how I would remember this equation. Okay? So where does this come into play? So if you guys have taken physics or engineering from me, or if you're taking physics right now, you know that when you're doing work, this portion of this vector does nothing for you because it's 90 degrees to where you want to go. Okay? Imagine trying to push a box here. The vector that's going up here does nothing for you when you're pushing the box over here. It is only this portion that does work for you. And this is exactly why we want the projection of a certain vector onto something else. Okay? So let's see if we can use this on example number 5. So let's do example number 5 and see how it works out. Example number 5 says find the vector projection of u onto v, where u is 6, 2, v vector is 5, negative 5. 5, negative 5. So we're projecting u onto v. So again, I'm going to end up with a v vector direction. Okay, so up here I will have u dot v, and since I have v here, it's going to be squared as such. And again, this is notated projection of u to v, projection of u to v, okay? So all I'm going to do is go ahead and now plug in chug. So I'm going to do the dot product of these two, which is going to be 6 times 5 is 30, 2 times, so it's minus 10, right? The math... Huh?
Can you move the camera down? Like,
Oh, I see. I got it. That's about as... Oh! Technology, you gotta love it. Maybe I should just not use the bottom of the board. Still the same, right? I'll just use the top of the board. How's that?
No, that's better.
Is it better? Can you see the bottom now?
Yeah.
Okay.
I can't see the bottom.
No, you can't see the bottom, but there's more of the board.
Okay, let me see the bottom. I'm gonna not use the bottom. So I'm gonna go ahead right back up here. So we're back at the projection of u vector to v, and we were at u dot v squared v vector, right? Where u was 6, 2, v was 5, negative 5, okay? So this is where we were. Okay, so the dot product is 6 times 5 is 30. 2 times negative 5 is negative 10. The v is the magnitude here, so the magnitude would have been what? Square root of 5 squared plus negative 5 squared. But it's this guy squared, right? And then I'm going to have the v vector itself, 5, negative 5. Okay? So what am I going to get here? I'm going to get 20. And this is what? 50. 5, negative 5. So this is... Let me know when I go too low and you can't see. Everybody see where I get from here to here? So I go from negative 2 divided by 5 times 5 is 2. And this guy times negative 5 is negative 2. Okay, so that's where I got that 2 and negative 2 at the end. All right? So, every time you see a question like this on the test, it's going to ask you to find not only this guy, but it's also going to ask you to find this guy. Okay? So this was the u. This guy here is what? The projection of u, well, if we call this u1, where is that? u1 is right here. This is u1. This is the projection of the u vector onto the v vector, right? So this guy here, we'll call this u2. So what happens all the time? What happens is that you're going to find that the actual u vector itself is u1 plus u2. Can you see that? U vector here is u1 plus u2. Okay? So I know what this was when I started with. This was 6 and 2. And I found u1 to be 2 and negative 2. Now I just have to find u2. Okay? So to find u2, I just move this guy over. 6, 2 minus 2, negative 2 is u2. So u2 is going to be equal to what? 6 minus 2, which is 4. And then I have 2 minus 2, it's going to be 4. Okay? So the question is going to ask you to find not only the projection of u to v, but it's also going to ask you to find U2. And this is how you find U2. Okay? All right? Okay, let's move on to example number 6. Example number 6 is finding a force. Example number 6. In example number 6, you have a guy on looks like a inner tube going down a snow hill, and you have some guy holding on to him to make sure he's not falling down. Okay, so this is the hill. I have the guy sitting on the inner tube, and he's going to have a certain amount of weight. And that weight, the combined weight was 140 pounds. So this is 140 pounds. Okay, 140 pounds. Now the guy who's holding on to this, by the way, this guy was 45 degrees. If you look at the guy who's holding up this way, okay, because he's trying to prevent this from falling down, okay? What's actually happening is this guy is counteracting the part of the red that is as such. You see that? So if you call this vector is equal to this vector plus this vector here, the purple one is counteracting or counterbalancing this guy here. So what you need to find is the directional vector, this vector, which direction is going first, okay? So if you look at the direction of this guy looks like what? This guy looks like 45 degrees, right? So this guy, the directionally is going to be what? Is going to be 1 and 1, right? 1 and 1. Everybody see what I mean by 1 and 1? I go 1 over here and 1 up here, right? So that's 45, 1 over here and 1 up here, okay? The book actually wants you to do this in a unit vector. If you do this in a unit vector, what do I get? Unit vector is this divided by its magnitude, right? Correct? So that would be 1, 1, root 2, which is the same as 1 over root 2, 1 over root 2. So this is not the actual magnitude of this vector, but it is the direction of this vector. Now I'm going to go ahead and project this vector onto that vector. Okay? So if I do that, I get what? So I am projecting this guy, which is 0 and 140, actually negative 140, right, which is going down this way. I'm projecting this vector onto this vector, okay? So I'm going to get what? Dot product. And the vector itself is this. Then I have to square this, right? But since it's just a unit vector, what is the magnitude here? It's 1, correct? So it's going to be 1 squared as such. Okay? So let's go ahead and find the dot product here first on the top. Dot product is what? This is 0, and then I'm going to have negative 140 over root 2, and that is that part, and that guy's just 1, and I'm going to multiply that by as such. So what do I get? Negative 140, negative 140? That doesn't sound right. Is that good? Okay, what am I missing here? Oh, I'm doing two things at the same time. let's go ahead and find this guy here first. Okay, let's go ahead and find this guy here. So if I find this guy, what do I get? So this will be what do I get here? This is 45 degrees, correct? This is 45 degrees. So what do I get here? What is the magnitude here? The magnitude here is what? Is 140 divided by root 2, right? Because I have 1 to root 2. So this is 140 down here. So this guy here is that, which is 70 root 2, because I can do this, right? That would be 2. And divide that, I get that. So this magnitude here is this. So, but I'm going in which direction? I'm pulling it that way, right? So it would be, the counterbalancing force is that way. So it would be this. Is that the answer? Negative, because it's going down this way. Okay? All right? So if the book did it in standard vectors, so it's going to be negative 70I plus negative 70 root 2J. Okay? So that's that. Let's look at the work. Work is something, again, if you're in my engineering class, or if you were in physics, this is review. Again, like we talked before, let's say that if I had a box, and I'm pulling this box with a certain amount of force, I'm pulling it. Do I want to pull it this way, or do I want to pull it this way? If I'm trying to pull it this way, I want to pull it exactly parallel to where I want to go, right? Because if I pull it this way, I'm only this amount of the work is actually doing something for me. Okay? So the work is equal to the force vector, the dot product of where I want to go. Okay, and the book says AB, whatever, okay, same thing, right? So if I had a work and I'm going this way, right, this is theta, my work is what? This guy, the amount of work that actually I'm doing is what? Cosine theta, right? It's a cosine of this theta because that's the amount that's actually doing work for me. This is the portion that's actually doing work for me right here. And this is what? If this was F, this guy here is this guy times this guy, right? And the D is just the distance that you traveled. Okay? So let's go example number 7 and see if we make any sense of this. Example 7. Find the work done by a 10-pound force acting in the direction of 1, 2, and we're going from that to that. So, okay, so I have, the direction vector is 1 and 2. Okay, and I'm going from here to here. Right? So the direction vector is what? The direction vector is from here to here, so it's going to be 3 and 0, whereas the force vector is 1 and 2. Okay? So the work, we're trying to find the force, what are we trying to find? We're trying to find the work. Okay, so the work is what? F dot D, which is 3019 1, 2, 3 plus 0, 3. That's not correct, is it? So the force, so this is the force here, right? So the force is that, 1 and 2. So the work actually going this way is what? This is going to be just 1, right? So yeah, well 1.3, it should be 3. What are we trying to find though? Okay, so the way that the book did it is that the force is 10. Oh, so the force is 10. There's a magnitude here. This is what I'm missing. There's a magnitude of 10 here, right? That's the magnitude. This is just the direction here, okay? The direction is going this way, but the magnitude is here. So the force is going to be not this. The force is going to be 10 magnitude of, but it's in this direction. Since it's in direction though, so I have to make this a unit vector because I don't want to add any magnitude from here. So it's going to be 1 squared, 2 squared, which is 10 root 5, 1, 2. Okay. So the work is going to be, again, this. And the force I found to be this. So it's 10 root 5, 1, 2, dot product of D, 3, and 0. So it's going to be 10 root 5, and now I do the dot product here. I get 1 times 3 plus 2 times 0, 30 root 5, which is actually 30 root 5, and root 5. This becomes 5. 30 divided 5 is 6. 6 root 5 is your answer. Okay. And that's it. I am done. So 6.2 homework will be due on Friday. Now before we go, I want to get a kind of a feel to see how this is working. Is this working better for you than me just posting videos, or is there any benefit in me actually doing this in a Zoom? Anybody?
I think it works good for the Zoom and also YouTube. Since you are doing a Zoom, and we can, like, the people who's here can just answer the comment, and then who is not here, we can still look up to YouTube.
Okay, hang on a second.